All right, example 4. It says write the inverse and contrapositive of the conditional statement. If two whole numbers are both even, then their sum is even. What are the truth values of the inverse and contrapositive? So, first off, I want to clarify something that maybe I made sense of before, maybe I didn't. I want to make sure everybody gets this. If it's talking about a conditional statement is of the form, if something happens, then something else happens. That's a conditional statement. Let's use capital letters instead of lowercase. So, if P, then Q. If hypothesis, then conclusion. The word if is not part of the hypothesis. The word then is not part of the conclusion. P and Q are the statements of hypothesis and conclusion. All right? So anytime they ask you for a conditional statement, you should have an answer looking like that. If something happens, then something else happens. All right? Make sure that you always write conditionals in if-then form. It's the best way to write them. All right? What we learned already last session, 1.5 day 1, is the converse of a conditional statement has the structure if Q, then P. All right, so it swaps the hypothesis and conclusion of your statement. That's how you make a converse. All right, and what we found out, hopefully, was sometimes the converse is not true just because the conditional is true. And sometimes the converse is true and the conditional is false. Sometimes they're both true. We'll talk about that in a moment, another problem. All right. That's what we've learned so far about conditional statements. So if this was the problem, and it says find the inverse, I would say if two numbers' sum is even, then they are both even. I would just swap the hypothesis and conclusion. Again, they're not asking for a converse here. It says find the inverse and contrapositive. But again, if they said that, I'd be able to write it. The inverse says if not P, then not Q. And they do use symbolism. They don't write the word not. That little squiggly in front of P means not P. What not P should be would be the most completely opposite idea possible. All right, and we'll talk about what that means in the context of this problem in a minute. But sometimes it's a matter of making an opposite word. If it says if the students are happy, then something happens. Maybe you say if the students are sad. Okay, but then not happy be even more opposite than sad, right? Because you could not be happy, but maybe you're not sad, maybe you're just discontent. Or maybe you're a little bit under the weather, whatever. So you want to be more rather than less obvious when you're being opposite. So if we take a look at this problem, if I'm asked to do any of these things, inverse, converse, contrapositive, first thing I'm going to do is I'm going to identify what P and Q are. All right, so if I'm looking at this problem here, this conditional statement, and I locate the word if, the words following the word if represent the hypothesis. All right, so the hypothesis, P in this case, are the words two whole numbers are both even. Okay. Notice I did not write the word if. I only wrote the words after the word if. Okay, so again, for my original conditional statement, that's what P is. If I locate the word then, the words following the word then represent the conclusion of the original conditional statement. So my original conclusion is going to be their sum is even. Now I will do one thing here I want you to get a habit of doing. I want you to at least mentally identify pronouns. Because when you write a good sentence, you don't put pronouns in the first thought. If he liked baseball, then George would be playing baseball, right? You would say, if George likes baseball, then he would be playing. So the first thought's where you put the name, the second thought's where you put the pronoun. So if we're swapping some stuff around here, we might need to change where the pronoun is. Now, can somebody tell me what a difference, what the opposite of both even would be? Not even. Not even, okay? That's close. Odd is close. All right, if both are even, give me an example of what that would look like. What would both even look like?
4 and 2.
4 and 2 would both be even, right? What would not being both even look like?
1 and 3.
1 and 3 both odd. What about 2 and 5? Are they both even? What about 5 and 2? Both even? No. So, and I think Drew said odd. Odd is the opposite of even, right? But if we say both odd, then they both have to be odd. But if I have one odd and one even, they're not both even. So if I'm looking at this and I want to make a negation, because this says if not P, all right? I need to make sure that when I write not P, I have to make the complete opposite of this. I need to take in everything that isn't that. So what they've given me here, both even numbers, I've got an even number and an even number. So 2 and 5, or 2 and 6, 4 and 4, 16 and 44. They have to both be even. The set of numbers that aren't both even would be either two odd numbers, the first odd, the second even, or the first even, the second odd, right? That's everything that's not even, not both even. So the way you make a negation here, if I want to make not P, I'm going to put the word not in front of both. Two numbers are not both even. That allows me to have two odd numbers, one odd, one even, in whichever order. And again, you need to make sure you get as completely opposite as possible. If there's like a, I don't know, let's say I've got a group of like marbles, and I've got some red marbles and I got green marbles. What are the primary colors? Red, yellow, and green? No, red, yellow, and blue? Red, yellow, and blue are the primary. So let's say I had red marbles and blue marbles, and I wanted marbles that are primary colors. It's all of them, right? If I wanted only red, the opposite would be not red, which is blue, right? But again, in that case, it would be easy. Whatever is not one is the other. But here, if I say are both odd, that's not getting in the possibility of one odd and one even. So when you're making opposites, make sure that the complementary set is everything else could possibly happen. That's what you want not to be. Okay, so if you think of all the things that could possibly happen with numbers, with two numbers, you can have two evens, two odds, first even, second odd, first odd, second even. They're only giving you the both even possibility. To get the not that, you got to put not in front of both. Okay. Their sum is here. I can just put, to make not Q, I can say not even, or I can say odd. You know, it's just even or odd. If it's not even, then it's odd. If it's not odd, it's even, right? So it's fine to use the word odd there, but again, to say both odds, not exactly making the opposite of that statement. So, if I'm making the inverse, and I've already established what not P and not Q look like, I'm going to write it like this. The inverse, I'm going to write inverse, you spell inverse, INV, period. I need to write a conditional statement because an inverse is a conditional statement, and it's going to be constructed of these two things with if and then thrown in. So, I'm going to write if two whole numbers are not both even, then their sum is odd. Okay. And the problem asks us to do two things, actually three things. It asks us to find the inverse and the contrapositive, and then state the truth value for each conditional statement. So, this is our inverse. There's a conditional statement. Again, it's an if-then statement. It's just, I took what they said and I've modified it based on what an inverse is. Now let's look and see if this is true. Now I could build a truth table for every one of these possibilities. To me, it's easier just to look at the basic truth table idea. If you have true, true, it leads to true. If you have true, false, it leads to false. That's basically what you need to know. Other than that, if the hypothesis is false, it's irrelevant. The answer is true. So if you're looking for the truth value, there's how true and false happen. You make this true, you see if it's always true. The conclusion is always true. So let's try it out. Two whole numbers are not both even. So again, what are the three possibilities? We have odd, odd.
Odd, even.
We have odd, even.
Even.
And we have even, odd. Those are the three ways to make this happen, right? So two whole numbers are not both even. They look like one of these three scenarios, right? Okay, let's try an odd plus an odd. Tristan, give me two odd numbers.
3 and 5.
Perfect. If we do 3 plus 5, what do we get?
9.
8. All right. So 3 plus 5 equals 8. Their sum is supposed to be odd, is 8 odd. No. So I can see right away that it's possible to make this happen, right? Again, the hypothesis can be true with 3 and 5, but the conclusion does not hold true, right? So this is false. Anytime I consider a conditional statement to be false, I want to give a counterexample. And the counterexample here is going to be Tristan's 3 plus 5 equals 8. Okay. 3 plus 5 represents two not both even numbers, and the sum is not odd. So it didn't work out. 5 plus 5 equals 10. 9 plus 9 equals 18. 65 plus 3 equals 68. Anything where you show two odd numbers adding up to an even number. These two would have worked though, right? 5 plus 2 is 7. 16 plus 3 is 19. So these two scenarios worked. This one didn't work. And because we have the ability to make the hypothesis happen without the conclusion happening, the conditional statement is false. So again, how we build an inverse is we identify P and Q, we create not P and not Q, and then just write proper if-then form. Right? So to make a contrapositive, contrapositive is just the converse of the inverse. So you switch the order and you negate it. So you put not Q first, you put not P second. So we've already established what not P and not Q look like, right? We do have this pronoun in Q, not Q, so we're going to have to fix that. But notice, I'm going to use the same wording, I'm just going to change the order. And again, I'm going to modify where my pronoun is. So I'm going to say if the sum of two whole numbers is odd, then they are they are not both even. Let's take a look at that. So again, all I did was I just put if not Q, then not P. I already had what the words were supposed to be. I just had to construct a proper sentence out of it. I did modify the pronoun usage. I changed there into two whole numbers, and I changed two whole numbers into they.
So you have to put that last part for your answer.
The contrapositive, yeah, this is the contrapositive. Contrapositive. So let's see, compos. Let's say compos.
I'm like out of room.
What?
I'm like out of room right
You're fine. You'll just kind of squeeze it in somewhere. We only got one more little thing to do here with this. Okay, so if I want to find the truth value of this, I'm trying to construct a sum of two numbers that is odd. So I've got some number plus some number equals an odd number. Okay? If it's false, that means I can find two even numbers that add up to an odd number. Because again, they are not both even, right? So if I say 2 plus 5 equals 7, that's odd. If I say 5 plus 2 is 7, that's odd. In both cases, those are both not even, right? I could go 9 plus 9, but that I don't have to pick. I just have to have an odd sum, right? 9 and 9 don't add up to an odd number. The numbers add up to an odd number. It has to add up to an odd number. So if I do odd plus even, I get odd. If I do even plus odd, I get odd, right? If I do even plus even, I get even. So this wouldn't be happening. So again, the numbers that work here is either odd plus even or even plus odd. That's the only way to make odd, right? When I'm adding two numbers, that's it. There's no other way to do it. If I'm adding two numbers up, One's odd, one's even, I get an odd sum. If I add two odds, I get an even. If I add two evens, I get an even, right? That's the only two ways to make odd, right? So I'm getting an odd answer. This is the only two ways to do it, is either way, have both even. Is this both even?
No.
Is that both even? No. So they're not both even. Always true, right? If I'm getting an odd sum, the only way I can do it is if they're both not even. We didn't get the odd-odd scenario, it doesn't matter, it doesn't have to. I just know there's no way to make even happen, right? If I'm getting an odd answer, even's not happening. So this is a true statement. So my contrapositive is this, and it's true. One thing about contrapositives, they're always true if the original's true.
So to show our work, should we just put like,
Now this would be showing your work here where you went through the thought process of it.
would it also work if we just put like 5 plus 9 equals 14?
Well, 5 plus 9 equals 14 wouldn't fit the description of this because we have an even sum, right? We want an odd sum.
Or, oh yeah.
So
well,
5
I
plus
just
5 plus 8
Yeah.
equals 13 would be
Yeah,
fine.
that's right.
But again, just show me that you went through the thought process at least to see it's not possible to get two evens in that scenario. So that's all we had to do. It doesn't matter what it looks like as long as it's not both even, because that's what it says. If the sum is odd, the numbers we're adding are not both even. Well, they're not both even in either scenario that could possibly work. All right? So that's how to make a contrapositive and an inverse. All right, and again, contrapositive is always true if the original is true, just to let you know that. So if you can't figure this one out, you go back to the original. Well, if we have two even numbers, they have to add up to even. 4 plus 4 is 8, 6 plus 6 is 12, 4 plus 8 is 12. It seems like it happens every time, so we can just do that too.